Okay, so last thing we've got to look at here then is how we can put molecules into a mass spec and what that shows us. So the molecule goes into the mass spec and it gets bombarded by high energy electrons, just like the element did, and that knocks an electron off and gives us a positive molecule. So it's just like the original molecule but with a positive charge. So that can now be detected by the mass spec. We call that the M+ ion or the molecular ion. And that will give us the molecular ion peak. The molecular ion peak is always the heaviest one because nothing can weigh more than the molecule itself. So it's always one furthest to the right. So in this case we've got 3 carbons, 8 hydrogens, that adds up to 44. So the MZ value furthest to the right is molecular ion peak for the propane ion here, positive ion, and that will have a MZ value of 44. Okay, so it's always the one furthest to the right. Now we can get more information than that because we can get fragmentation patterns too. So that molecular ion has been hit by a high energy electron. It's got a lot of energy, it's vibrating, it's shaking, it splits up. Okay, when the bonds breaks, fragments. So these two are fragments of the original thing. So this one wouldn't show up on the mass spec because it's neutral, but this one would. Okay, so CH2, CH3, a positive charge would show up and that have a mass of 29. And there it is. So the molecular ion is still there because not all of it will fragment, only some of it. But here's the peak at 29. Now it can split the other way, so the plus charge is on this part, and that is a CH3. That weighs 15 carbon plus 3 hydrogens is 15. So it's got an MZ value of 15, and that shows us the fragmentation pattern for this particular molecule. Now, you could get other ones as well. You could just get one hydrogen break off, so you could have one at 43. But each time it's just one bond that's breaking for each peak. And the pattern you get is always the same. How many times I put propane into the mass spec, I'll get exactly the same fragmentation pattern. So it's used to identify exactly what molecules are. Because we have a database of all these fragmentation patterns and compare our molecule spectrum to that, and from there we can work out what we've got. Okay.